All right, we're going to pick up where we left off last time, and we're going to expand this formula from the short formula of elasticity, which is percentage change in quantity demanded. Again, if we're looking for elasticity of demand, it's going to be QD. If we're after elasticity of supply, it would be ES, and this would be a QS, and everything else would be the same. It would be elasticity of supply equals percentage change in quantity supplied divided by percentage change in price. That's the only difference. So now we're still sticking with our demand curve. So we're going to be talking about elasticity of demand, ED, and we have a QD up here, okay, for quantity demanded. So let me pick an abstract number, and I'll call that, well, I'll call it P1. P1, because the first thing we want to do, if we want to calculate the elasticity of demand over a section of this demand curve, we have to pick a point, and we'll call that point 1, and we'll pick another point, we'll call it point 2. It doesn't matter if you make this one point 2 and this one point 1. It doesn't matter. The important thing is you call one of them point 1 and you call the other point point 2. Now, if we have a point on the demand curve, for every point on the demand curve, it has a price associated with that point, and it also has a quantity associated with that point. Similarly, if we come down here to point 2, it has a price associated with that point, and it has a quantity associated with that point. Now, I could put price as $20 and $10 and $1,000 and $6,000 here, and we could do it with numbers. We could do it with numbers, but I don't want to do it with numbers. I really want to do it with just symbols, and then we'll go back and we'll do one with real numbers here. So right now, we're not going to put numbers in here. We're just going to use these symbols that represent two numbers. And our task is to calculate the elasticity of demand over this section of the demand curve, from point 1 to point 2 on the demand curve. So let's go back to our formula here. And we say, okay, well, the elasticity of demand is percentage change in quantity divided by percentage change in price. So the change in quantity is going to be this big number less this smaller number, and the difference between those two, that's going to be the delta. That's the delta. That's the change. As we go from 1 to 2, that's the change. So that we can start out with getting this delta Q by saying Q2 minus Q1. That's the delta. But we don't want just the delta. We want the percent delta. Well, we got to have a reference point. We got to divide it by a reference point. At this point, most textbooks use the midpoint formula. That they say, well, don't use the first number like we did in our illustration in the last section. Don't use the second number. Really add them together, divide by 2, and use the average between the two. That's just a standard we'll use. So we'll go with the midpoint formula of our reference point being the average of these two. So to get the average, we've got to add them together and divide by 2. So that would be Q, right for me here, Q2 plus Q1 divided by 2, and I'll just say multiplied by 1/2. Now, what is above this line is percent change in quantity demanded. Percent change in quantity demanded. That is percent change in quantity demanded. If you can memorize that, I told you had to memorize this thing, right? If you can memorize how to get a percent change in quantity demanded, you take the big number and you subtract off the small number and you divide it by the average of the two. At this point, it's like shooting ducks in a barrel. I mean, you've got it memorized. It might look ugly when we're done, but it's a piece of cake now, because how do we get percentage change in price? Very simple. You take out the Q's and you put in the P's. So now we would have P2 minus P1, and we're using our midpoint formula, so we're going to be using the average of the two as our reference point. So it's going to be 1/2 of P2 plus P1. Now, you smart mathematics majors out there, you already know that I could probably cancel out my 1/2s, but I'm not going to because I want to just keep the symmetry, keep the logic, just so we can see the logic of what's going on here. Okay? Now, at this point, if I just said, oh, by the way, you've got to memorize this midpoint formula of elasticity, and it's Q2 minus Q1 divided by 1/2 Q2 plus Q1 divided by P2 minus P1 divided by 1/2 P2. It was kind of like, oh, I got to memorize. I can't remember. Does the minus go in the top or does it go in the bottom? And are they switched down here or are they the same? Now, all you have to do is memorize this guy. If you memorize this guy, you can derive this guy. You don't even have to memorize it. And I always like being able to create my own, derive my own formula, rather than, okay, I got to memorize this formula. Do you have to memorize this formula? Yes, you have to memorize this formula. But do you have to memorize it directly? If you don't memorize it directly, then you have to know how to get it from the one I told you did have to memorize, because you will be doing this formula on exams in this course. So now let's take it, and I'll just make up some numbers here. And let's say that on a test, you are asked to figure out the elasticity of demand over this curve, and I give you a graph, and for this number here, I'm going to try to make this as easy as I can because I don't know how it's going to turn out and the math could get hairy, but I'll just say from $120 down to, this is dollars here, down to $100, and from 240 units up to 340 units. Okay. So you're just given this demand curve, and you're asked to compute the elasticity of demand from the price of 100 up to 120. Between the price of 100 and 120, there you are, there's the piece of paper. Figure out the formula and write down the formula and input the data and calculate the price elasticity of demand. How would you do that? Now, as you recall, I told you never forget the easy step. The easy step is to make one of the points point 1 and the other point 0.2. It doesn't matter if you get them mixed up. It'll come out the same. You'll get the same number, but you got to make one 1 and the other one 2. So we'll just leave it like that. Now at 0.1, there is a price for 0.1 and there is a quantity for 0.1. Is there not? That's the axis there. That's the name of that. And for 0.2, there is a price for 0.2 and there is also a quantity for 0.2. Don't forget that. Just go one small step at a time. Now, you're going to get credit if you get the right answer. By far and away, the students who know how to do this don't get credit because they go too fast. They begin to skip steps. They don't call this 1, and they don't call this 2, and they don't write P1, Q1, and P2, Q2. They know what they're doing, and they just go, and you miss one step, and you get the wrong answer. You don't get credit for wrong answers. So now, what is P1? Well, let's look over here. It looks like 120. So we'll put 120 right there. So it's right beside our P1. And what's our Q1? 240. So we'll put our 240 right there. Okay? Now what's our P2? It looks to me like it's 100. We'll put it right beside it. What's our Q2? 340. Now I know what you're thinking. I don't have to move it from here to here and from here to here. I can figure out what it is, and when I go to plug it in my formula here, I know. I'm just telling you, the majority of the people who miss this are the people who skip these steps, and they want to go from here, without doing this, right to here. Word of the wise, don't do that. If you do it and you get it right, hey, great, wonderful, no problem. But I'm recommending that you just take your time, you just go through it. What normally happens is that a student will go straight from this, they won't do this, they'll plug it in and they'll get a number. And then they'll complete their test and they're about ready to turn in and go, well, maybe I better check it. So they go back and they check it and they get a different number. Was the first one right or is the second one right? So we do it again. But it would be a whole lot easier if, as you do it, you make this breadcrumb trail of where you got your numbers from, and when you check your answer, you don't have to do it over again. You simply check your steps. Is P1 really 120? And is P2 really 100? And is Q2 really 340? And then you just check your steps, and you don't have to do it over again and get a different answer, and then you got to check which one is right. It'll just save you time if you do it this way. Now, once we know the numbers, now and only now, we're ready to plug the numbers into our expanded formula. So if you help me out here, Q2 we said was 340, and Q1 we said was 200, put our minus sign there, minus sign here, 240. We're going to divide that by 1/2 times the sum of them both, 340 plus 240. Now, I have no idea how this is going to turn out because I just made these numbers up on the fly. But we're going to continue to plug and chug here. What's our P2? Our P2 is 100 minus our P1. Our P1 is 120. And we said to get percentage change in price, we got to divide by a reference point. So we're going to add them together, divide by 2. So that's 100 plus 120. Divide by 2 is the same as multiplying by 1/2. Okay. Now I'm going to be running out of room, so I'm going to erase this and come back around. But let's see if we can just boil it down a little bit more. 340 minus 240, I think, is 100. And this number right here looks to me like 580. Does that look like 580 to you out there in TV land? If I could write 580. 580. So 580 divided by 2 is 250 plus 40. 290, does that look pretty good? 290. So we'll put 290 in here. Now we've got to work on the bottom half. If I shouldn't be sloppy here. You go too fast, that's when you make mistakes. Now we got the top half. Now let's go down to the bottom half. 100 minus 120. Now I'm going to stop there for a second. Yeah, I know it's a negative 20. And when we divide that by, let's see, this is going to be 220. Divided by 2 is 110. And notice we got a negative sign here. This is the top number. This is this guy up here, percentage change in quantity. We're going to boil it down some more. This is the bottom number. But notice we got a negative sign in there. We've got a negative sign in there. Now, since demand curves always go from the upper left to the lower right, this calculation will always give us a negative number. That's simply because it is a negative slope. It's not a positive slope, it's a negative slope. But we're not after whether it's positive or negative, we're really after the absolute value of that. So you know what we do with that negative sign? We just forget it. We just forget it. Because we know we're after the absolute value. Now let's boil it down a little bit more. I don't have a calculator here, but I think we can get rid of these two zeros. We get rid of these two zeros, and that gives us 10 over 29 divided by 2 over 11. 2 over 11. Now this is kind of ugly when you get a fraction divided by a fraction. It's called a complex fraction. And assuming we've done everything right, I hope. What do you do when you have 1/2 divided by 2/3? 6/5. What do you do with that? Well, you could take your calculator and you get 0.5 for this, and you get another decimal and you do the decimal. But one thing you could do is you leave the top alone and you just invert and multiply, so the 5 goes on top and the 2 goes on the bottom, and then you multiply tops times tops and bottoms times bottom. Question? Oh, no, we got a signal. We got a signal. All right? So let's do that. Let's do that very quickly. And I don't have a calculator with me, but we're going to say, okay, 10 over 29 times 11 over 2. And then we're going to get a number like this times this is 110. And that would be 230 is 60, 58. 2 9 18, 58. And then we would take this number divided by this number. And the point is, this is going to go into that, and it's going to go in at not quite twice, but it's bigger than 1. If the number is larger than 1, then this portion of the curve is elastic. This number right here, if it's bigger than 1, it's elastic. Now, how big? What is the difference? That is what this number tells us right here. Okay, I'm running out of time here, and so now you know how to take the numbers and put it in here to calculate this number right there called elasticity of demand. You do not worry about the negative sign. Do not worry about the negative sign. We're talking about the ratio of this to this, and that's what we're after when we're talking about elasticity.